Research Methods, Assignment 6, Lizzie Thompson. Firstly, we have descriptive statistics and inferential statistics. So measures of dispersion include standard deviation and range. Standard deviation is the range around the mean, and the range is the difference between the highest and lowest numbers of the dataset. Measures of central tendency are the mean, median, and mode, and the mean is the average, the mode is the most common within the dataset, and the median shows the middle value of the dataset. Here we have the distribution curve. The distribution curve shows how the data is gathered, and it should look like the example to the right hand side. The picture there shows a normal distribution of the data gathered. The skewness shows where the peak of the curve is, and the kurtosis shows how flat or steep the curve is. This is shown here. Inferential statistics. Inferential statistics test for relationships or differences within a dataset. Their main role is to prove that the relationship or difference wasn't due to chance. Within sports science, there is a 5% level of acceptable chance and a level of significance of 0.05 or less. This means that the data gathered within sports science, there is only a 5% chance that the results are wrong or down to chance. Therefore, the results gathered are extremely reliable. Parametric vs non-parametric. Depending on what type of data that is being used, there are two types of inferential tests. The first one being parametric. This test is used for ratio and interval data, and non-parametric is tested with nominal and ordinal data. So the Pearson's product moment correlation coefficient is testing for a relationship, and therefore the type of the test is parametric, whereas the Spearman's rank order correlation is non-parametric, but it also tests for a relationship as well within the data. T-tests test for differences within the data, and they are parametric again, whereas the Mann-Whitney-U also tests for differences but are non-parametric. The inferential test. There are two types of t-tests, independent and dependent. The independent are the tests that test for different groups or the same group doing different things. Therefore, the results can be compared to one another. Dependent are tests the same people doing the same thing twice, so they can look for similarities and differences within the data, as they've done it twice. Firstly, the t-test. This is a parametric test that tests for differences. It is dependent, so the same people doing the same thing twice, or independent, that has two groups doing the different things. It only tests two datasets and therefore analyzes this data. It tests for a relationship, which means the data must have similarities with one another. Pearson's product moment correlation coefficient. This is a parametric test again, and it also tests for a relationship. Correlation shows the strength of a relationship, whereas to see if it is positive or negative. This is known as the R-value. This test determines whether the data is significant or not, and it also tests for two variables. Mann-Whitney-U. This test is non-parametric, and it is equivalent to the independent t-test. It is needed for ranked data, or data that is not normally distributed, and it tests for a significance and the mean of the two independent groups. It requires two samples of the same size to work efficiently. It will produce a U-value at the end of this, and this U-value is used to determine the level of significance of the data. Spearman's rank order correlation. This is a non-parametric test, and it is the equivalent to the Pearson's test. It should be used when the data is ranked, and it uses ordinal data because of this. It will look for a relationship between the two datasets to look for similarities again, and it uses the R-value. It uses the R-value to determine whether the strength and the significance of the relationship. Research-based example. For my example, we were trying to find out a relationship between shoe size and jump distance. We collected it in a field-based environment. So we went down to the sports hall, collected shoe size, we collected the data, and then we did the standing long jump, and therefore we collected that data as well. This data collected was then inputted into a computer. For this we use descriptive statistics, so mean, median and mode.